In part A, I will introduce Grab's company background, key data sources, and why data governance matters. Grab was founded in 2010 as a ride-hailing company in Malaysia. Today, it has become a Southeast Asian super app covering mobility, deliveries, and financial services. It operates across 8 countries and more than 900 cities. In FY 2025, Grab reported total revenue of $3.37 billion and achieved its first full-year net profit of $268 million. It also has 129 million annual transaction users, showing the large scale of its digital ecosystem. Because of this scale, Grab manages 5 major types of data. This includes customer and user data, transaction and financial data, operational and logistic data, sales pressure and mapping data, and merchant and partner data. These data domains are closely connected. For example, customer location data supports ETA prediction, delivery routing, dynamic pricing, fraud detection, and even credit scoring. Therefore, data governance is the trust layer behind Grab's analytics. If the data is incomplete, delayed, depleted, or poorly protected, the analytics results will become unreliable. For example, missing GPS points may cause inaccurate ETA prediction and poor driver allocation. Delayed transaction data may weaken fraud detection. Inaccurate alternative data may also lead to wrong-graded scoring decisions. The risks are not only operational but also regulatory and reputational. For example, the 2019 Grab Hitch incident exposed the personal data of 21,541 users, and Grab faced several PDPC enforcement actions between 2018 and 2020. So, for Grab, data governance is critical because it supports compliance, improves decision-making, reduces risk, increases operational efficiency, and enables innovation. In short, trusted data is the foundation of reliable analytics and better business decisions. And I will pass it to Yukun.
Now let's look at how data actually flow through Grab, 8-stage end-to-end. Then start with the generation. Every write, every field order, and the Grab page section creates data, and let data get collected through a real-time stream like Kafka and API endpoints. And there is a procedure which is clean up, duplicated, standardized, and clean data is stored in the unified cloud data lake. And stage 5 is management, arguably the most critical. Grab uses LLMs to auto-classify over 20,000 data entities by sensitivity and enforce access controls. After that comes analysis, and with data scientists build model for ETA prediction, fraud prediction, and pricing. Those output feed into visualization, which dashboard and reports teams use daily. And finally, interpretation. Executives turn through insights into strategy decisions. The key point is that these stages are tightly coupled, and if something breaks upstream, the error cascaded all the way into decision making. And next is the fifth weakness. The once data duplication, cross-border use get recorded separately in each country, inflating metrics like MAU. And two, the second is streamer drift, which is inconsistent farming across pipelines. 4 decimal place upstream, 2 downstream, that cause the error in financial reporting. The third is latency gaps, which is some feeds still run on the back snapshots every 10 to 15 minutes, meaning the files models work with the stale data. The fourth is the weak change management. In 2019, a routine development exposed over 21,000 use data, not a hike, but the internal process failure flagged by the Singapore PDPC. The fifth is overclassification. The LLM stream texts roughly have all tables as tier 1, blocking analysis from non-even sensitive data and slowing down the analysis cycles. The bottom line is that the life cycle is well designed on paper, but these 5 gaps directly affect the analytics accuracy and the speed, which is why we need governance framed in Part C and D.
So at the top, the chief data officer sets the enterprise-wide data strategy, ensures compliance across all 8 countries, and chairs the data governance council. Below that, data owners, typically VPs or directors of each business segment, are responsible for the quality and accuracy of data within their domain. They authorize what data can be shared and with whom. Data steward handle the day-to-day execution. One critical task they perform at Grab is verifying the classification text generated by the LLM system. Even though the AI processes over 20,000 data entities, human verification remains essential to catch any false labels on sensitive personal data. Data custodians primarily from Grab's Caspian engineering team implement the technical infrastructure. Finally, data protection officers operate at the country level across Grab's 8 markets, ensuring compliance with local regulations like the PDPA in Singapore and Malaysia. So next, to make sure this ownership model actually delivers results, we've designed 3 accountability mechanisms: a quarterly data quality scorecard for peer accountability among data owners, a monthly data governance council for cross-functional issue resolution, and an event-driven incident escalation protocol, which became especially critical after Grab's data breach fine in 2020. Together, these rules and mechanisms form the foundation for the comprehensive governance framework that will be presented in Part D.
So we know who owns the data. Now Part D is how. We designed a governance framework for Grab built on 8 components, grouped it as policies, standards, and process, all serving one goal: data that's accurate, consistent, accessible, and compliant. It all starts with policies and standards, and this rests on 3 pillars. First, access. We use attribute-based control, so what you can see depends on your role, the data style, your purpose, and your jurisdiction. Second, privacy. Every change that touches personal data needs DPO sign-off before it ships. And third, security. That means AES 256 encryption and dynamic masking. But rules only work if someone owns them, which brings us to roles and responsibilities. Here, owners, stewards, custodians, and DPOs each carry a clear mandate, and they all answer to a CDO who chairs the Data Governance Council. With the rules and the people in place, we then turn to the data itself. Data quality management runs a 3-tier process: profiling, cleansing, and monitoring, to keep data accurate, complete, consistent, timely, and valid. And alongside it, security and access control use column-level access, so analysts can query exactly the column they need while personal data stays masked and every request is logged. So that covers the rules and the controls. Now for the final 4, which makes the framework scale and make it auditable. First, data classification. Grab's LLM model automatically tags over 20,000 data entities into 4 sensitivity tiers. That single move fixes the old overclassification problem and saves around 360 person days a year. Once data is classified, we need to be able to find it, and that's the job of the data catalog. It's one searchable inventory, so teams can discover datasets across segments without re-requesting access, and spot duplicate before they spread. From there, data lineage gives us traceability. By following data from end to end, root cause analysis that used to take days now takes minutes. And finally, auditing and compliance ties it all together, with 3 levels of assurance: continuous monitoring, quarterly internal audits, and annual external audits for the PDPA and PCI DSS. So, when you put these 8 components together, each one closes a specific weakness from Part B: duplication, schema drift, latency, weak change control, and overclassification. And the result is data that's accurate, consistent, accessible, and compliant. Thank you.
So to make this concrete, here are the actual numbers behind 2 of those components. On the left, the quality threshold. These aren't vague goals, they are hard rules. Financial figures must reconcile across systems to within 0.1%. Mandatory fields stay under a 2% null rate. Customer IDs must be 100% deduplicated, streaming data fresh within a minute, and geolocation 100% in the country boundaries. So on the right, classification tiers. Personal IDs and contact info are tier 1, transactions and geohashes tier 2, operational KPIs tier 3, and public data tier 4. This is what drives the automated masking and access rules. Together, these turn the framework from a diagram into something measurable and enforceable. So in short, every one of those 8 components maps back to a state's weakness from Part B, which brings us to our conclusion. Trust is a layer beneath the analytics. Thank you.